Hello everyone, today we are here with another elementary number theory problem about prime numbers. So the problem is find all primes of the form n to the power n plus 1 which are less than 10 to the power 19. So observe that n to the power n plus 1 is very large number when n is large. So we narrow our search by the restriction 10 to the power 19. So let us solve this problem. So for n equal to 1 to the power 1 plus 1, that is 2, is prime. For n equal to 2 to the power 2 plus 1, that is 5, is prime. So n equal to 1 to, we got 2 primes. So for general case, we will first prove a result, then we will go for other cases. So our claim 16 to the power 16 plus 1, that is for n equal to 16, is greater than 10 to the power 19. So that is 10 to the power 19. Okay. So this implies proof. So now 16 to the power 16 equal to 2 to the power 64, that is equal to 2 to the power 4 into 2 to the power 60, that is 2 to the power 4 into 2 to the power 10 whole power 6, that is 2 to the power 4 means 16 into 1024 whole power 6. This is definitely greater than 10. 16 is greater than 10. This is greater than 1000 whole power 6, which is equal to 10 into 10 to the power 3 whole power 6. So that is actually 10 to the power 19. So this implies that 16 to the power 16 is greater than 10 to the power 19. So this implies that 16 to the power 16 plus 1 greater than 10 to the power 19. So n equal to, we will search for n equal to 1, 2 to 15, because 16 to the power 16 plus 1 is greater than 10 to the power 19. In the problem, the question is asking about to find all primes less than 10 to the power 19. So we will check only 1, 2, dot, dot, 15, these numbers. So 1, 2, 1, 2 we already have checked. So now for some general case, let n is odd number with n greater than 1, n odd and n greater than 1. Then n to the power n plus 1 is divisible by n plus 1, because we know that x to the power k plus 1 is divisible by x plus 1 when k is odd. That is very general result. X to the power k plus 1 is divisible by x plus 1 when k is odd. So here n to the power n plus 1, here n is odd, so n to the power n plus 1 must be divisible by n plus 1 for n greater than 1. So for n odd, n to the power n plus 1 has a factor dot n plus 1. So n to the power n plus 1 is not prime. not prime. So the odd numbers, that is 3, 5, 7, for those number n to the power n plus 1 is not prime. So now we'll go for n even. Now if n is even, then n is either 2 to the power k for some n equal to 2 to the power k for some k, or n equal to k comma d, where k is even or d is odd. So for any odd numbers, these are the form 2 to the power k or kd, where k is even and d is odd. So now if n equal to kd, then n to the power n plus 1, that is actually n to the power kd plus 1. Here d is odd, so n to the power k whole power d plus 1. But we know that x to the power k plus 1 has a factor x plus 1 when k is odd. Thus this has a factor n to the power k plus 1 since d is odd. So what we got, n to the power n plus 1 has a factor. So this case n to the power n is plus 1 is not prime. So these are the case where for example n equal to 6, because for example 6 means 2 into 3, 2 is even and 3 is odd. These types of number, these types of number. Now the remaining case, that is if n equal to 2 to the power k for some k, that is the remaining case. So in our example, our n is from 1 to 3 15. We already checked for 1 and 2, and odd numbers already checked, and product of odd and even already checked. So only the number remainings are n equal to 4 and n equal to 8, that is 2 square and 2 cube. So these form numbers, so 2 square and 2 to the power cube. Now if n equal to 4, then n to the power 4 plus 1, that is equal to 4 to the power 4 plus 1, that is equal to 257. It is easy that one can show that it is easy, very easy, that 2 to the 257 is prime. So we got another prime. Now the remaining number 2 to the power 3, that is 8. N equal to 2 to the power 3, that is now n to the power n plus 1, that is equal to 8 to the power 8 plus 1. 8 is 2 to the power 3 whole power 8 plus 1, that is 2 to the power 8 whole power 3 plus 1. So these has a factor 2 to the power 8 plus 1, because we know that x to the power k plus 1 is divisible by x plus 1 when k is odd. So here 3 is odd, so 2 to the power, it has a factor 2 to the power 8 plus 1. Therefore 8 to the power 8 plus 1 is not prime. So the answers are n equal to 1, 2, for n equal to 1, 2 and n equal to 4. These three numbers, that is, the numbers are 1 to the power 1 plus 1, 2 to the power 2 square plus 1 and 2 to the power 4 to the power 4 plus 1. These three numbers are actually prime of the form n to the power n plus 1, which are less than actually 10 to the power 19. We are done here. Thanks for watching. Please like and subscribe.